Have you ever stopped to think about what's stopping you from just being a puddle on the floor? Seriously, every time you jump or stretch or even just stand up, there's this incredible internal framework holding it all together. And it's not just a pile of dry bones. It's a living, intelligent system that's constantly rebuilding itself. Today, we're going to dive into that amazing architecture, the skeletal system.
All right, so here's our game plan. We'll start with the big picture, the overall design. Then we'll see how it's cleverly split into two major parts and look at the materials it's built from. After that, we're going to zoom right in on the bones themselves before putting it all together to see how this thing actually lets us move.
So, let's kick things off with the most fundamental job our skeleton has. And it all boils down to one simple but pretty profound question.
Seems like such a basic question, right? But the answer? Well, the answer is one of the most elegant pieces of engineering you'll find anywhere in nature. And there it is, the skeletal system. It's our body's framework, for sure. But I really want you to ditch that image of a dry, dusty skeleton from a science classroom. Your skeleton is a living, dynamic organ system, every bit as active as your heart or your lungs.
206. That's the magic number. That's how many bones make up the typical adult skeleton. And every single one, from the biggest bone in your thigh to the tiniest little bone in your ear, has a very specific job to do in this grand design.
Now, what's really fascinating here is that those 206 bones aren't just some big random jumble. Nope. They're brilliantly organized into two main subdivisions. It's like having two skeletons in one.
Okay, think of it like this. You've got the axial skeleton. That's your body's central pillar, your skull, your spine, your ribs. It's the core. And then you have the appendicular skeleton. That's everything that hangs off that core. Your arms, your legs, your shoulders, all the parts that let you actually move around and do stuff.
So here's the bottom line, the main takeaway. Your axial skeleton, that core, is all about protection. It's like a built-in suit of armor for your brain, your heart, and your lungs. And the appendicular skeleton, well, that is all about action. Grasping, walking, reaching, that's its job.
So, if we're building this amazing system, what are the actual materials we're using? It really just comes down to three key components.
First up, the superstars of the show. Of course, the bones. These are the steel girders of your body. They provide that hard framework, they shield our delicate organs, and they even act like a bank, storing essential minerals like calcium.
Next up, we have cartilage. Now, think of cartilage as the smooth, slick coating on the ends of your bones. Its whole job is to cut down on friction, kind of like Teflon on a frying pan, and to be a shock absorber, making all our movements fluid and painless.
And finally, we have the joints. These are the absolute genius connection points, the hinges, the ball and sockets, all of it that allow our bones to move. I mean, without joints, our skeleton would just be a rigid statue. They are the key that unlocks the potential for movement.
Okay, so we know bones are the main framework, but their job description is so much more impressive than you probably think. Let's take a closer look. Let's dive a little deeper.
So yeah, this is where the true genius of bone really shines. They don't just give us structure, they give us our shape, they protect us, they act as levers for our muscles to pull on, and they store minerals. But check this out. The last one is the mind blower. Deep inside, in the marrow, your bones are living factories, pumping out new blood cells. Your bones are absolutely living, working organs.
And this right here illustrates one of the most beautiful principles in all of biology. Form follows function. The shape of every single bone in your body is not an accident. It's perfectly tailored for the specific job it has to do. This principle gives us these different categories of bones. We have long bones, like the one in your thigh, which are perfect for leverage. We have short, kind of cube-shaped bones in our wrists that allow for all those tiny, complex movements. Flat bones, like in your skull, are like protective shields. And then you get the weird ones, the irregular bones, like your vertebrae, which have these unique shapes because they have multiple, complex jobs to do all at once.
Now here's a really cool detail. If you could look really closely at a real bone, you'd notice it's covered in all these little bumps and grooves and holes. So why is that? Why aren't they just perfectly smooth?
Well, they're called bone markings, and they are basically the connection points and the highways of the skeleton. They serve as anchors for your tendons and ligaments, or they create little channels for nerves and blood vessels to pass right through. They're the infrastructure built right into the bone itself.
For example, you might find a fossa, which is sort of like a shallow bowl on the bone's surface, or a spine, a sharp little projection that acts as an anchor point. You can actually feel some of these on your own back. And a foramen? That's simply a hole,
a perfectly designed tunnel for a nerve or a blood vessel to pass through safety. Every single mark tells a story.
So, we've got the framework, we've got the materials, we've got the connection points. Now for the grand finale. How does this all come together to let us actually move?
It's this beautiful, coordinated dance. The bones act as the stiff levers, the joints provide the pivot points, the fulcrums, cartilage, as we said, keeps everything gliding with almost no friction, and then, and this is the key, the muscular system provides the force, pulling on those bony levers to create every single motion you make, from running a marathon to just blinking your eyes.
And that really just says it all, doesn't it? It is not just a collection of parts. It's a fully integrated, incredibly elegant system where every component, from the biggest bone down to the tiniest little marking, has a specific and vital purpose.
So I'll leave you with this final thought. We've talked about the skeleton as a framework, but it's not a fixed one. It is constantly breaking down and rebuilding itself, so much so that roughly every 10 years you have an entirely new skeleton. The very core of your physical self is in a constant state of renewal. So think about that for a second. If your body's most permanent seeming structure is always changing, what does that mean for the rest of you?